The broadcast is now starting. All attendees are in listen-only mode.
Welcome everyone, and thank you for attending today's webcast, Plant 3D, the long and short of bolts at length. Our presenter today is Rick France. He is a solutions engineer with Hagerman and Company. Before we begin, I'll let you know that you are in listening only mode. If you have questions during the presentation, you can type those into the question panel, which is located on the right-hand side of your screen. They'll be addressed at the end of the presentation today in a Q&A time. As we close down later today, you'll be prompted to fill out a short survey, and we do ask that you take a few moments to fill that out for us. It is helpful in our webcast planning. Additionally, all registrants will receive a follow-up email tomorrow, which will contain a link for the recording of today's presentation. Now I'll go ahead and hand things off to Rick.
Well, good morning. Well, it's good morning for you guys. It's afternoon for me, but I am glad to be here with you guys this morning. We're going to talk about bolts and bolt links and how you control them in Plant 3D. And basically, here's a little overview. If I can get my screen to start working here. There we go. A little overview of what we're going to talk about here today. I'm going to start out just talking about how bolt links are calculated, not only in real life, but mainly how it's applied in Plant 3D. Then we're going to look at bolt length mapping and bolt compatible standards. They're two terms you're going to see a lot in the catalogs and other places of the software. They are interchangeable in my opinion. They mean the same thing, but they're just different parts of the software where you will see the terminology. But in addition to that, we will touch on some things that we did in the previous webinar called Plant 3D Connections that really class up a joint. In other words, we're going to look at some we're going to set up some plant EndCodes, plant connection settings, and then how those components and EndCodes and specs are all put together. We're going to take a look at doing some things that's a little bit different, not much than what we did in the other one. But that we're not going to spend a lot of detailed time on because it is something that was covered in detail in the other webinar. So we're just going to show you what you need to do as far as bolts are concerned. And then we're going to fasten it all together and show you how it all works together and fits and what makes these things tick. So first, let's talk about how it is out of the box. So let me switch up here on my screens. It'll take me just a second to, all right, there we go. All right, so this is just a little thing I drew up to work with out of the box. But basically it's just the bolts of some different components. Now, 3 of the components are custom components: the strainer, the reducing instrument valve there, and this relief valve. But I chose to use those. They've been done in other webinars and classes and stuff like that. I chose to use those because it makes it, they're already in my catalog, and you may have seen them before in different instances, and it'll make it real easy to just show you how some of this stuff fits together and changes we can make without having to copy stuff out of the box catalogs. So those are just existing components, but all the bolts right now that you see on the screen are using out-of-the-box bolts. And you can see here, this is an 8-inch pipe, this is a 10-inch. You can see here the 3/4 inch bolts, which are the ones on the 8-inch flanges, are all 4 1/4. There's a 7/8 inch bolt here. That is the 10-inch bolt there. And then you have some others here that are, again, out of the box, so they're all 4 1/4 inch long. So what we're going to be doing here is basically showing you how to manipulate those sizes both manually and automatically as I work through this process. Since there's all different bolt sizes, 1/2 inch, 5/8 inch, all that, we're not going to create all these different bolt sizes and things that deal with. We're going to deal strictly with the 3/4 and the 7/8, the ones that are used in this 8-inch and 10-inch pipe, just to make things a little bit easier and faster to show. Now, I'm going to erase some objects here and get us down to just the T. And a piece of pipe coming off here, and that's just to be able to add some components after we make some changes. So this is where we're going to start. And part of what we need to do here is first talk about how bolts are calculated. So basically, this is rudimentary for most of you. If you're piping designers, you already know in real life, you calculate a bolt. The length of the bolt is basically the nut, the washer, and the thread, plus the flange thickness, plus the gasket, and then flange thickness, plus the nut, washer, and thread. So that's pretty logical. But most of us don't actually go around calculating that out. And by the way, flange thickness is usually, doesn't matter whether it's a raised face or not. That's always a standard flange thickness there. But we usually don't sit there and do the math. I can't tell you the last time I do the math. Most of this stuff we can find in charts. For instance, if you look for a flange chart online, again, there we go. My mouse keyboard wasn't working. So if you looked at a flange chart online, you will see. Now I'm going to deal, since we're dealing with 8-inch and 10-inch, but we're going to mainly be dealing with this 8-inch pipeline. So that's what I'm going to show in the charts here. When you look at that 8-inch chart for a class 150, that's the pressure class we're using, you'll see the thickness of the flange is 1.12 inches. See that on pretty much any chart, any brand you look at, any book, they're always going to be the same for a class 150 flange thickness. And then when you look at flange bolting charts, you will see that for an 8-inch flange, it's 4¼ inches long. So that's kind of the standards we see in there. So instead of having to do that actual math, we just look at charts usually. Well, Plant 3D is not much different. When you look at the bolts in the catalogs, you will see for an 8-inch one that they've got the flange thickness set to 1.12 inches, just like the chart. And they've got the length set to 4¼ inch, just like the chart. However, they realize that not always flange thicknesses are the same from component to component when you're dealing with different valves and things like that. So they made the flange thickness the variable in the formula that they use. So when you're looking at Plant 3D, bolts are calculated basically as the length of the bolt, 4¼ in that particular one that we're looking at, minus 2 times the flange thickness of the bolt, 1.12, plus the flange thickness of component 1 plus flange thickness of component 2. That equals the length rounded to up to the nearest 1/4 inch. Plant 3D always by default rounds up to the nearest 1/4 inch. So looking at that a little bit more than what we were looking at earlier, you've got the bolt length being 4¼ You've got your flange thickness 1.12. Then we have, let's say, a flange on that's a standard flange, and its thickness is also 1.12, so that would be flange thickness 1. But let's say we have a valve where the flange thickness is 1.25 inches long. That's where this comes into play, because that would make it different. So in essence, in that situation, you take 4.25 minus the 1.12 times 2, which is 2.24, plus the flange 1, which is 1.12, plus the valve 1.25 equals 4.38, which is 4 3/8, rounded up to the nearest 1/4, 4½. That's the formula Plant 3D uses. It sounds a little complicated, but it gives you multiple areas where you can manipulate these bolt lengths depending on your situation. So that's where we're at. And that's what we're going to take a look at. We're going to take a look at first the rounding, how that is done. So we're going to switch over here to our catalog. And in our catalog, we're going to open up the spec. So I'm going to open up the spec here. And for this project, I'm using class 150, so I'm going to open that spec up. When I do that, it opens up all my catalogs that are being used in the spec, because that strainer and those 2 instrument valves are in my Vandelay catalog, which is my custom one. It also got opened. So that's the one we're going to do all our work in. So I'm going to come over to the catalog editor with Vandelay open. So I'm switching over to the catalog editor. Now, here's the rule number 1, or law, whatever you want to call it. This is not a suggestion. We're going to be dealing with what's called the bolt mapping standard, or bolt mapping links and bolt compatible standards. When you're using a bolt mapping length or a standard, whatever you want to call it, when you're using those, they have to be in the same catalog as the bolt that is referencing that standard. So I cannot have a standard in the out-of-the-box catalog and use a bolt in my custom catalog to reference it. Likewise, I can't use a bolt from the out-of-the-box one and have it reference one in my custom catalog. They have to be in the same catalog. And I'm a proponent of separate catalogs so that when I go from one version to another, I don't have to transfer all these different settings over from one catalog to the other. I can just point at my new catalog and go, my specs will work in the same catalog. I've been using these same specs for years and not having to do anything to my catalog because I keep all that customization separate. So that's why I'm going to put not only my bolt mapping standard in my catalog, I'm going to have to put bolts that reference that standard in the same catalog. So here's how we do that. Come up here to catalogs. Again, I'm on the catalog editor in Vandelay catalog. I'm going to come up here to my catalogs, and under there, you'll see edit bolt length mapping. Now, out of the box, there's always two in every catalog. Two default ones. You can't delete them. They're there. And as you can see in my catalog, they're not even filled out. It's because they don't get copied from the out-of-the-box catalog to here. There's one out of the box is all set to 1/4 inch of settings. There's no reason for me to copy it over here because it's going to default to 1/4 inch no matter what, unless I change that in the out-of-the-box catalog. But then I'm going to be doing that every time I upgrade, so I'm going to leave that alone and do it just with my own bolt standards here. I'm going to set up one that's going to be for 1/2 inch, rounding to the nearest 1/2 inch. I'll set up another one for rounding to the nearest inch, and then I'm going to set up a custom one that just does random numbers. So we're going to add a bolt standard here, and I'm going to call this one, well, I need to get it. I've got it copied into a notepad here so I can just copy and paste it and not lose it. It is very important when you're setting up these standards. You can use spaces, you can use punctuation and everything, but it's got to be matched word for word, letter for letter. And that also means it's case sensitive. So when I create the bolt, that standard has to be, when I'm telling it what standard that bolt's using, it has to match this right here exactly. Upper, lowercase, everything. So that's why I like to do the copy and paste. I just put it in my notepad so I don't have any mistakes. Now I'm going to be creating 3 different standards. Now I'm doing this for a couple of reasons. One, just to show you some examples. Another is to show you different methods for getting the bolts into your standard. Because who wants to type thousands of bolts into a standard? So the first one I'm going to add here is that 3/4. I'm only doing 3/4 and 7/8. And here's rule number 2. Always use the inch sign. That also has to match the bolts. And since the bolts are labeled as 3/4 inch, you have to use the inch sign. If you just put 3/4, it won't work. Here, though, you don't use inch signs. That's just the way it works. So here on the length from and the 2, I'm giving it a range. I'm going to give it a range of 2.5 inches to 14 inches. And I'm going to make it increment every 1/2 inch. So it's only the bolt size you need to worry about using the inch sign. Here, it won't even work if you use an inch sign. I'll show you what I mean. I'm going to put 2.5 inch, and you see it gave me a red with the exclamation point. Yeah, can't use the inch sign here because this is going to be where it's doing math. So I'm going to say 2.5 to a 12 every 1/2 inch right there. Once I'm, oh wait, this is the I one. This is every inch. So let me change that to 1 and this one to 1. That's why I put the I on there is for inch. So once I've got that set, I'm going to hit OK. And there you have it. They put it in every, oh man, because I said 2.5. Let me redo this one now. Remove it. I want to start with the H one while I'm thinking 1/2 inch. All right. Since that was in my brain, I should have changed that to the 1/2 to begin with. So we're going to do it. That was a little mistake on my own part. Sorry about that. I won't talk as much while I'm doing this one. So it went from 2.5 to 14 every 1/2 inch. And then this one goes 7/8 of an inch. 2.5, 212 every half inch, and there we go. So I'm caught back up. So there's my H version, the half inch, and you can see every half inch it's incrementing for the 3/4. There's the 7/8 exactly as I put in the range. So I'm going to add another bolt standard. This one I do mean to be I, and for 1 inch, and we'll do 3/4 of an inch again. And this time I'm going to say from 3 to 14, so I'll make sure I've got even numbers every inch. And I'm going to show you another way to get the 7/8 inch one in here without having it, because if you were doing this, as you can see, there's the every inch. If you're adding the half inch to this H1 or 5/8 or any of the others, you may not, if you don't put them in all at once, you may come back and do it later. And here's how, because I can't just add a range in here. It won't let me do that. But what it will let me do is come in here and give it the exact same name, make sure it's imperial, and I can add a range in here where I'm adding another bolt standard, 3 to 12 every inch. And what happens when I hit OK this time, I can either go back and change that standard name since it already exists, or I can append this to the already existing one, which is what I want to do. And now I've got both the 3/4 and 7/8 inch in the same ASME B1.2.I. Now I'm going to add another standard. This one's going to be kind of a unique one that's going to be random numbers. So I'm going to call this one, just do the 3/4 inch, and I'm going to make it go from 3 to 14, incrementing every 3 just to get some in there. And that got those in there, and it's just another way to show you that even after they're created, I could come in here and change them manually. I'm just going to pick some numbers here about every 2 inches. Actually, we'll just leave that one 12. Why not? So 4, 6.5, 9, 12. Let's go ahead and make one more in here, and I can actually add these after the fact, on the fly, one at a time. So it's one at a time. That way they still have to have the inch sign. Everything has to be right. We're going to add those ranges. Now I am purposely going to leave 7/8 inch off of this one. This is the one that will connect to that 10-inch pipe and need a 7/8 inch bolt. And I'm going to purposely leave it off so I can show you what happens if you add a bolt set at that time that doesn't exist in this standard. That way you'll know. I also need to show you one more thing about this before we leave the bolt standard at this time, and that's metric bolts. Because just like the 3/4 inch, you have to make sure when you're adding a metric system, we'll call this one DIN 931, it's going to be metric. It has to be M, capital M, 10, or whatever size it's going to be, but you have to have the capital M in there for it to work, just like you had to have the inch sign on the imperial, you have to have the capital M on the bolt size for it to work. And we can do also here, we can also do ranges, say every 5. I could do another one, let's say M10 from 60 to 100 every 10. So the same bolt size, 2 different ranges. And it has no problem handling that. And I can always come in, I can put them in out of order. I'll just add a 75 in there, and that's okay. It doesn't matter if it's in order. Once I hit OK here, if I came back to it, you'll see they're actually in order. So put 75 back up there. So it doesn't matter if you put them in the right order or not, they'll sort correctly. And again, just like I did earlier when I made that mistake, if I don't need one, just remove the bolt standard. You can remove a whole one like that if you don't need it. So we're just going to be dealing with the 3 though. The H for every half, the I for every inch, the C for the custom one, which has those kind of oddball numbers stuck in there in different, no particular sequence. But that's the way you create your bolt length mapping, which is your bolt compatible standard also. However, they won't be used unless you have bolts that reference that standard. Now, I don't have any bolts in this catalog, and I don't want to create them from scratch. So I'm going to come over to, I'm going to save this thing first. I'm going to come over to my ASME pipes and fittings catalog. This is a pressure class 150. It's raised face. And I just want studs, so we'll say STU, and there's the stud bolts that are in that ASME catalog. This is actually the exact same one that's in my spec right now and what's being used in the project. I want to right click on that one and say copy, and then I'll come back over to my Vandelay catalog, my custom one, and I'll paste it. Right click and paste, and now I've got a bolt literally created completely with all the sizes. It's an exact duplicate of the one in the out of the box catalog. But here's where I'm going to make a change. Now, because I did that copy and paste, I lost my this one in there. So I'm going to copy this information, the name of my bolt standard, back into here. And right here it says bolt compatible standard. You can see it's set to ASTM A1. The out of the box, the bolt standards there, but when it doesn't exist, it just automatically uses the default to the nearest 1/4 inch. But I want it to use, in this case, my I one, which is the inch one. So I'm going to make this one the inch one. Notice I do not have bolt compatible standard down here to search through, but I do have design standard. So I always like to make my design standard and my bolt compatible standard the same, so I have the way to sort and search for them. So I'm going to go ahead and add that same name to my design standard. The only one that matters to the software is the bolt compatible standard here, referencing the bolt length mapping. This is just for my convenience. Once I have that set up, I've literally got that bolt set up. I can just hit save to catalog. I'm done with it. I don't need to do anything else unless I want to play with numbers or something elsewhere. In this case, I don't, because I like everything to read the same. I just want to have the links different. I'm going to duplicate it. Just remove the word copy. It doesn't matter. It'll let you do multiple bolts with the same name in the same catalog. And so all I have to do in this one, I'm going to make it the H one, and I'm going to make the standard H. I've created another bolt with another standard. I'll duplicate it again. Create it. Change the H to C. Change this H to C, and now I have a bolt created. Save it to the catalog. I've got 3 different bolts, each one set to a different standard, which I've already created in the bolt length mapping. The only other thing I need to do to make this work is come over to my spec editor, and I'm going to add all 3 of these bolts to my spec. Now these came in without any part use priority setting. There's all 3 of them. They all look the same name because I wanted them to have the same verbiage in the bill of materials and stuff. But part use priority, I'm not going to change. I'm not even going to bother setting it because this is the one that was out of the box, which is my default, 4 1/4 inch length on those 8 inch ones. And I want it to maintain that as my default. And there's more reason to it, which I'll explain in a minute when we're actually looking at this in just a second. I want to save this to my catalog. Then I'm going to switch back over here to the project. Now to make my spec update, I'm just going to toggle from one spec to back to my carbon steel 150. That gets my spec updated in my project. And for this one, I'm just going to put in the check valve. Same check valve we had in there originally. Still an out of the box check valve. Nothing's been changed on it. But as you can see, at this time, the bolt set is using the same 4 1/4 inch bolt because that's my part use priority. However, if I go to my bolt set here to change it, holding my control key to pick it, and then the part substitute, you can see there's my 1/2 inch one. Here's my inch rounding one, and here's my custom one that was going from 4 to 6.5. So it's calculating everything based on the default one, 4 1/4. But I have options to pick a different one. So I could literally pick the 5 inch one here. And the only thing that really changed was my lung description size. And if I went over there and looked for size, that changed. My bill of materials will be correct. Everything though, the only thing that I physically see is I chose the 5 inch bolt instead. Now here's why the part use priority is important. Whenever you change these manually, if I go back here, notice I no longer have the 4 1/4 or the 4 1/2. Even the lug bolt is now calculating on the 5-inch. The one larger, 6 1/2 is available, but everything's 5-inch. If I chose that 6 1/2-inch one, come back in here, everything's now on the 6 1/2, but this one's 7-inch one. That one's there because it can go up to a 7-inch now, but it's going to, I lose the lower version. So if I had a part priority set to the 6 1/2, I would not see any of the other ones or have a method to change back to them. So you want your part use priority back here to always be your smallest length bolt. And you want it to default to that one. If you don't do that, you have no method to change here back to one of the smaller bolts. So that's quite important as far as the part use priority part. Now, if I need to get it, I've set it here and I need to get back to one of the smaller ones, I can literally delete the bolt set and tell it, hey, let's connect component to the adjacent, connect it there, and I'm right back to the default of 4 1/4. So at this point, what you see is I can set this bolt standard and these bolts up, and I can manually change from one bolt's length to another and have those options in my project. But I want to take it a step further. I want to be able to automatically have it assign a bolt length to certain components, or to automatically assign a rounding to certain components. And I can do that through the EndCodes and the connection settings. And this is what was in that last excuse me, what was in that last webinar. I couldn't think of the word. The last webinar I did, which was that Plant 3D connections that really class up a joint. So this is what we covered in detail in that one. So I'm only going to do enough to show you how to set this stuff up initially when it applies to these bolt standards. So the first thing I need is a plant EndCode. So I'm just going to open up the plant. Got to spell plant right. Plant EndCodes. You can see I've already created an EndCode for the flange, the C version, and the H version. I figure, why do you don't want to sit here and watch me do the same thing 3 times over and over again? So I'm going to add a new one. This one's going to be my flanged inch one. And I'm going to call it flanged ASME B1.2.I, and it's going to be flange-like. That's all I need to do to set up these flanges on the EndCode. So I've got 3 of them created, all of them the exact same way. They're just each one referencing C to C, H to H, and I to I. That's the only difference between the 3, but I have 3 different EndCodes, one for each standard. That's the first part in getting this to be automated. So we'll hit OK. The second part of getting this automated is to go to those plant connection settings in your project setup, or piping connection settings rather. And once it opens up here, there we go. I'm on piping connection settings, and you can see I've also already created the H and the C one. I'm just going to be adding the one for the I. So this is where I'm actually telling it when it uses these EndCodes to which standard to use. So I'm going to add one. Again, I'm not going to spend detail of every step here, but this is going to be FLI, and it's going to be flanged ASME B12I. I'm going to set up a hierarchy here. You can see up here I've got flange and flange H going to flange H. This one's going to be, if it's flange or flange H or flange I, it will connect up to flange I. I don't want to connect up flange C to this one because I want to make, here I'm trying to tell it, basically if an H connects to an I wins. If an I connects to a C or an H connects to a C, C wins. So I'm setting up a hierarchy here. So I don't want flange C to connect up to this one. I want flange I to connect up to flange C. So basically I'm telling it these 3 instances connect up to I. That's when I want it to use this end connection. Just like in any other flange connection, we have to add the properties that we want to make sure that the connection is valid. This was all covered in the other class, so I'm not going to go through it, but it's basically nominal diameter, pressure class, and facing, that's the same as the ones out of the box. So I set up those properties. So I kind of flew through that, but that's because it's covered in detail in the other one. I'm just setting up those 3 properties, so to be the matching values. Lastly, I do want it to have a gasket, and I do want it to have a bolt set. And the bolt set's where we're going to vary from the other webinar, because here's where I want to tell it when it's using the FLI connection, which compatible standard it's going to use through the spec filter. So with bolt set selected, I select spec filter, and you can see at the top there's bolt compatible standard. So I'm going to activate that and set the value to my bolt standard, the I one. This has to match identical, just like the bolt had to match the bolt standard, word letter for letter, case for case. This one does too. That's why I like to copy and paste them. But this one has to match, or else they'll never sync up. So I'm telling it that that's the standard I want to use. I'm going to go ahead and say okay, and there you can see it's all done. I'll add it. So now I've got this piping connection for those set up. Now, since FLI did not exist when I created the C one, I need to add it there. So I'm going to modify it and add FLI so that flange C, H, and I connect to flange C wins. And just like the other one, so you can see it's set to a bolt standard of C. So these are all created the same way. But here I've told it which ones, I've built this hierarchy of which ones, what situations a certain standard gets used. Now I also want it to happen automatically as I draw, just like it does out of the box. So I need to add to the auto flange down here. Another thing we did in detail in the other webinar, those 3 connections. So I'm going to modify the auto flange and add flange C, flange H, flange I, modify, I'm done. Hit OK, and that's it. That's all I need to do to get this set up. Now, again, if you want to know more detail about those 2 topics, if you go to the Hagerman.com website, under events, you'll see webcast on demand. Click on it, select plant design, and then you'll see here's plant 3D connections that really class up a joint. I just went to more info, but this is the other webinar I was talking about, which is kind of a prequel to this one. So this one has all the information in detail of what I just did with the plant EndCodes and all that. The only difference is we didn't have a bolt compatible standard in that one to have to set up. So that's the main difference between what we did in that webinar and this one. Now, that guy has Plant 3D set up and my project set up. That's the EndCodes are for all projects. The piping connections are per project. That is one thing to also remember. But over here, back in my catalog, now that I've got that done, I'm going to go back to the catalog over here. So what I'm wanting to do is set up those EndCodes to be used by these 3 components right here. So I'm going to set 1 to the H, 1 to the I, and 1 to the C. So I'm going to start with the strainer. We're going to make the strainer the H one. And all that's necessary is to change the end type here from flange to flange H. That's the one I'm going to use for it. There's 2 ports, so I have to do that for both ports. Now notice I am doing each port individually. There's a reason for that. For some reason, if they already existed in my project at one time with the flange connection, if I use the all ports have same properties, it will tell me in the catalog it's been assigned to both, but it doesn't actually come over assigned to both in the project. So since I'm in an open project that's already used these parts, I'm going to have to set each one individually. The raised face pressure class doesn't matter. This is strictly something to do with end types. So I've set the end type for port 1 and port 2 on the strainer to H. I'm going to take this reducing valve here and I'm going to set it to flange I. There's the one we just created. And then I'm going to go to port 2 and do the exact same thing. If I don't, by the way, if I did the all ports have the same properties, the only thing I can do is go to each drawing and purge them to get them out of the system, and then that would work. And this saves me from having to purge it by doing it one at a time. So the relief valve, same thing. This one's going to use the flange C in connection. And I'm going to do that also on both end types. And I'm saving each one to the catalog. So pretty much that's all I needed to do to get EndCodes set up, which one it's going to use. Just set the end type in the component itself, and then that points it towards the piping connection, and then that points it towards the bolt standard. A little jumping from one to the other. However, if I want to use those parts that I just made changes to, I've got to update them in my spec. That means I've got to come over to my spec and remove the current ones. I'm going to remove the two instruments. Then I'm going to remove the strainer. Then I'll come down here and I'll add, whoops, let's get them sorted right. And I'll add all three of these to my spec. Save it. Now watch what happens. Come over here. I need to update my spec and my drawing. We've already got the check valve there, so we're going to connect the strainer up to that one. So this is FLH. See, it says FLH for the end type there. We'll set it up. So I've got flange to flange FLH, and then I'm going to have FLH to FLI, which then has FLI to flange. And then we'll do the pressure relief over here, which will be flange to FLC. We'll go ahead and add the 10-inch line here, which I normally wouldn't, but it's just to be able to show the bolt sets, what happens on that one, because remember we did do a 7/8 inch one for that side, particular type. Let's go ahead and take a look at what happened here. So here, didn't mean to hit it twice. Now I got to hit it a third time to get them back in order. All right. I've got the zoom turned off, but it will highlight. So this first one, which is flange to H, 4.5 inches. Went to the nearest 1/2 inch. This one is the out of the box flange to flange. It's still at 4 1/4. So is this one here, which is flange to I, 5 inches. This one here's H to I, 5 inches, the I1. This one here, now this is my 3/4 from flange to a C, which went to the 6.5, because remember I did that one for 6.5, 9, and 12, 14. So it calculated to the nearest one, which was 6.5. And this one, which is the 10-inch, 7/8 inch, didn't exist. I didn't have that one. I remember I left the 7/8 inch off on purpose. So what it did was it defaulted to the one out of the box. Everything's being calculated off 4 1/4. I haven't changed any bolt links, so they're all being calculated off 4 1/4. It's all in the rounding. It's what those bolt standards are doing. So I'm getting different links based on the roundings. Since I didn't have 7/8 inch in the bolt standard to round up to anything, it just defaulted to the one out of the box, 4 3/4, the nearest 1/4 inch. I want to fix that. And there's a couple of things we have to do to fix that. So first, I'm going to go ahead and delete these. And because I want to show you some other methods of what will affect these bolt links, I'm going to go ahead and replace all 3 of these. We'll just keep the one check valve in there. Let's go back to our catalog. So back over here in the catalog editor, we're going to make a couple of little changes so you can see some things that will happen. I'm going to start with the relief valve here, not the strainer. I'll start with, actually, no, I'm not going to start with strainer. I want to start with the, the bolt mapping. Let's go and edit the bolt length, because here on C, I want to go ahead and add 7/8. Just to save time, though, I'm just going to add 1 in here, and I'm just going to make it 10 inches, just so it's kind of really out there compared to other stuff. That way I know it'll get to that one. So I'm just going to add that 1. Now, because I changed the bolt standard, I have to update the bolt in my spec that uses that standard. But I'm going to make some other changes, so I'm just going to update all of them here in a minute. but you'll see it when I get there. So that one, because I changed the the C standard, I have to update that bolt in my spec, because that update will not pick up unless I remove the bolt from the spec and add a new one. But let's go to the relief valve. If you remember in our calculation, we can change the flange thickness of a component. So I'm on the 8x10 one, which is the one I was using in my drawing. And I'm going to change the flange thickness right here, and I can affect the bolt length by changing that. I'm just going to make it an even 4 inches. So this one's going to be 3 inches longer, but since it's the one that is in the weird C one, it'll change it from 6.5 to 9 inches. That's the one it'll pick, but I'm going to let this change the length of the bolt that it's using for the rounding itself. Let's change, I'm going to save that. Let's change a bolt. Here, right here, let's do the H one. The C one we're going to change anyways because we changed that bolt standard. But H one here, for this one, I'm going to remember we can also play with the thickness here because this gets subtracted. So think of it this way. 1.62, I made it a 1/2 inch difference. That's not going to make the bolt a 1/2 inch longer. That will actually make the bolt 1 inch shorter because it's going to subtract that number from the length. So it's now a 1/2 inch longer. That gets multiplied by 2, so it's actually going to take an extra inch. So where the old one was 4.5, this one will be 3.5 inches long, all because I changed the flange thickness right here that gets subtracted out of it. But it's going to show you how that flange thickness of the bolt will affect your length. We'll save that to the catalog. And then on the I one, which is this one, you can see the I down here. This one, I'm going to change the bolt length. That's what it starts with. So if I changed it to 6.25, then the calculation is going to be 2 inches longer than what it was to begin in the previous version. So we'll save that to the catalog. Those 3 changes to bolts, the one to the relief valve, I need to get in my spec. So first I'm going to grab these 3 right here, remove them from the spec. We'll then come down here and find that relief valve, remove it from the spec, and then down here, I just need to add these 3 back in so that those changes get picked up. And I'll add the relief valve so that change gets picked up. Save it to my spec, and let's see what happened. Again, we have to toggle to get my spec to update in my drawing. Let's see, we'll add the strainer right where the same place it was. We'll add the pressure reducing valve, same place it was. And we'll add the pressure relief valve, add the 10-inch pipe, and let's take a look at our bolts. So you can see this one right here. That is the one on the top of the tank there. It's still 4 1/4. All right, there's the one that I made that flange thickness of the bolt a 1/2 inch longer, 1.62. So it actually calculated 3.5 inches long now instead of 4.5 inches. So if I made that flange thickness smaller, it would be long than 1.12. It would calculate longer. If I make it larger than 1.12, it calculates smaller. But that's where you can control using the flange thickness of the bolt how long bolts are. This one here, that's the 10-inch one. Notice it's going to 10-inch now because we set in the standard 7/8 inch, 10-inch. So now it's rounding up to 10-inch, where before it went to 4 3/4. Now it's doing it to 10 like I wanted to because I added it to the standard. This one here, that's the one out of the box, nothing changed. All right, this one was 5-inch. It's the H to I and the I to flange. They were 5-inch before. I made it longer, 6.25, so now they're calculating up to the next one, which is 7 inches, because I made the length of the bolt longer in that one. And then the last one is, this is where I added 4 inches from 1.12 to 4 on the flange thickness of the component. So now it's going to the next available size, which is 9 inches. So I'm able to affect all these different sizes using different methods. So let's look at those methods one last time before we call it a day. Basically, it's the length of the bolt minus 2 times the flange thickness of the bolt plus the flange thickness 1 and 2 equals L, and it rounds up to whatever one you're using. So we changed in one of them the length of the bolt to 6.25. That made it basically 1 inch longer, or 2 inches longer, because we made it, it was 4 1/4. I changed it to 6.25, and that made it change from 5 to 7. So changing the length of the bolt itself in the catalog changed the way it calculated that one bolt. Only the one that I changed the size to. We changed in another one the length of the flange, or the flange thickness. That one's the one that was the 2 times flange thickness. So by changing the length of that flange thickness larger, it actually made the bolt smaller automatically. The next thing we did was we also changed the length of the bolt flange thickness on a component. That was the relief valve, and when we changed it from 1.12 to 4, it actually made it go to the next one size available in that particular standard, which was 9 inches. But when it was 1.12, it went to 6.5. And lastly, we spent a little bit of time on these different bolt standards. They affect the roundup. So each one of those areas of that formula can be manipulated to get different bolt lengths. Most of the time for me, the bolt standard's all I have to worry about. But there may be certain situations where I need one of the others. All of them can be combined and be used at the same time. I used them in different components and different standards to where I didn't have things overlapping. It was hopefully easier to follow and understand by that. But they can all be combined into one bolt. It's totally up to you how you use it, but you can actually do this. And as you saw in the very beginning, we can manually change to any bolt that we have using any standard in the particular project. So that's how bolts are calculated. We're going to answer some questions. So let me go over here and see if there are any. And for that, I need to open this up. You would need, okay, here, let me make this, I'm going to pull this off where I can actually see it a little bit better and stretch it bigger. All right. Got several different questions here to start with. We have a client that requires an extra 2 inches of bolt length for all insulating kits. This requires a normal length and a longer insulating length option for all flange components. Is there a preferred method for capturing this without cluttering the catalog spec with custom components to match the 2 different compatible standards you would need? The only way you're going to be able to do that is to have a component that uses a bolt standard that's going to connect up. If they're going to be an extra 2 inches, yeah, you're going to, I would say that one, you're going to have a component that has that extra flange thickness. That's the way I would do that one, of the 2 inches for that particular component. Because other than that, even if you tried to make it calculate to a roundup of every 2 inches, there's that chance that one calculates to, let's say, 4 7/8, so it's going to calculate up to 6, and another one that's 5 7/8 is also going to calculate up to 6. So to get the extra 2 inches of bolt length per component, you would have to do that in the flange thickness. Let's see, the next one. I haven't figured out how to, I'm not usually the one doing this part of it. It's usually somebody else that's doing this. So I think that's the only question. That's the reason I don't see anymore. So right now, that's the only question. I'll give you a minute or so if somebody has another question. In the meantime, while we're waiting for that, let me mention to you that there are different classes that we offer in Plant 3D and P&ID. We have a quick start 1-day class, which is an introduction to P&ID. We have a 2-day advanced class for P&ID, which is basically setup and customization on the P&ID. We have a Plant 3D new user class for experienced CAD users, so you're expected to know how to use AutoCAD. You don't have to know how to use the P&ID portion to do it. but it does help, and that's 3 days. And then the advanced for the Plant 3D side for 2 day, which what we're doing here would be considered advanced stuff if we actually did this in the class. This is not a subject I normally cover in the class. One of the reasons I did the webinar. Just to let you know, these training classes build on each other. So by design, the quick advanced P&ID picks up where the quick start P&ID leaves off. The new user plant picks up where the P&ID advanced leaves off, and advanced Plant 3D picks up where the new user in Plant 3D finishes off. So they do help to take them in order, but they're not necessarily have to be. If you don't see a class you want on our calendar, please just contact your sales rep and they can get it put on there for you. And that's all I'm going to do. I see no additional questions. So since no others are coming up, I guess I will turn this over to Ashley again.
Okay, thank you, Rick, for the presentation, and thank you all for attending. Just a reminder that a survey will pop up as we close down today, and also another reminder that you'll receive an email tomorrow with a link for the recording of today's presentation. Thanks, everybody, and have a great day.